So I'm Fabienne. This is a video game project that I did where we built our own video game, we built our own avatar creator with a touch screen, and then you played your game by moving RFID card physically across your other opponents, and there were 4 RFID readers under the table, and then you had to move the your avatar, and dinosaurs were bad and banjos were good, and so we called it multi-knitting threaded banjo dinosaur 2D extreme or something like that. And the whole winners panel was knit because it was also in this 8-bit graphic style, and then we knit the whole winners panel to the ceiling and back down again, and you could see it from the street. So this is a project from a long time ago. You can pass it around. But that's how I got obsessed with knitting machines, and I come from a mathematics and classical music background by way of audio engineering, by way of now I'm a Unix geek, so I work as a sysadmin doing large storage clusters and all kinds of things. But I love generative art, especially generative art that I can knit on my machine. Yeah, so I think most of the examples I have here, I have a little physical thing you can touch, except for the very first example, which is Laura Kogler's Mosaic Knitting, and I'm going to show it to you here in a second, which is a software where you can, and I knit a scarf with this called the Algorithmically Morphing Scarf. So what I tried to do is not just put pictures of them up, but I also put exactly how I did them. So if you wanted to recreate or make an algorithmically morphing scarf, you know what my tension was, what yarn I used, what knitting machine I used, and so on and so forth, and why I made certain decisions about repeats and how it looks. And you could actually go ahead and clone this or fork it and make your own that's similar to it. So the links I put in that paste bin have the code. So what's cool about the algorithmically morphing scarf is that if you see somebody wearing it, you don't necessarily notice that it's that it changes actually until you look really up close. So I liked how subtle it was, but I think if I were to redo things, I would make it a little less subtle. And So Kano, who's here, one of our resident artists and technologists who's here at eTib, is working with Nukeme on making interesting pixel morphing patterns, and he has some really cool code to do morphings of houndstooth patterns and checkerboards, and to make them, you can see very easily that it's been morphed from one side to the other. So that's really cool. So you don't have to do super subtle things, you could make it more straightforward. Laura Kogler, by the way, has that scarf now. I ran into her in San Francisco and she said, "Oh, I know this project," and I said, "Oh, you saw it online?" She said, "No, that's my code," and I said, "Here's the scarf, you can have it." So I was, yeah, weird that I just ran into her at a friend's house in San Francisco, but yeah, very strange. The second example I have a knitted object here that you can pet. Someone will have to grab for me the hat that is on the sideboard there. But it's using the random squares pattern generator from Unicatissima. And what it is it's an algorithm that she wrote up as a web app, and I think it's all done in Java. And she, you can say, I want it to be this large and this large, and then it generates you a new one, and then you hit refresh and it will generate you another one. So it's noise. It's using a random number generator.
Oh, I need to share.
Oh, I'm sorry. Is a random number generator, and it works. It's really interesting also for single bed knitting. So if you're looking for things that look good, where you don't have to do double bed jacquard and you can leave the floats on the back and knit something relatively quickly, pain-free. This is also a really good pattern to use, or set of patterns. It's not open source. I think Laura by now, with the first one I showed, has released her work, but I haven't gone looking on her GitHub. But it's really awesome, and this is actually meant for hand knitters too, so or crafters. So this is something that people were like, "Oh, I want pretty Scandinavian designs that are generated," and yeah. I made also another scarf that I don't have here that was gifted, and there's a link to that one as well on my page. Things that are called cellular automata, which are generative designs that are let's talk about one-dimensional ones first of all that are generated with a rule, and then they generate down and they finish with a 2D image. So you finish with a flat image. Doesn't necessarily have to be in 2 colors because there's cellular automata that are in multiple colors, but the ones that are interesting in 2 colors, which look really good in knitting, are the what are called Wolfram 1D cellular automata, but some people would argue that Wolfram, they're not really from him. But they're called that. So if you Google that, then you can find it. All different rules. So I have some examples.
For the reading. Yeah, every day.
And then the purple and black one that is up there is Rule 110, which is my latest baby. So they're generated from one end down to the other. And what's really cool is that it's one of the basic examples in processing. So if you don't even know anything about software or anything, you could load processing, it's free, run it on your machine, and then generate an image. And you could also, I show you which values to tweak in my code so that you can make your own scarf so you don't just knit my scarf again. So I can show you that really quickly live. 1 second. What's cool also with, I made also a free script that if you generate, for example, one of each, like you make a thing that will auto-generate little squares of these generated images, then you can batch convert like 500 image files into the right format for my machine, which is 2-color bitmap. I use a hack that's a bit outdated, so I'm not using Knittic. I'm using the original old hack with a bunch of command line tools that are also on my GitHub. But I don't necessarily recommend that. I just love being in the command line and being able to get directly from what I create into what I knit to the machine. So what I've linked also in each of the examples in that pastebin that I showed that is, oh, no, we're not on that. In each of the examples on the pastebin, there's a link to another pastebin with the actual code that you can just copy and paste into processing and then run it right away. So this is an example. This is actually the code for that purple and black scarf that's right there. Very quickly play with the parameters to get one that looks different than mine. I like mine because it has this nice big gnarly chunk for a very long distance before it gets starts repeating. And I like the way that looks, but maybe you want something that's more repeating. So you could change, for example, the parameters. I'm just going to change one of the parameters. And on a different pixel, let's turn on pixel 40 and pixel 3 instead of 42 and 23. And then we can regenerate. So it's putting out an image, and you'll see that, well, that's also an interesting one, but it starts to repeat here, and then it has this like very long repetitive pattern at the end. But what's cool with having a script that you can sit there and play with the numbers is that you can find something that you like that is graphically pleasing to you, and maybe the numbers also have significance for you. I don't know how superstitious you are. I mean, it's bad luck to be superstitious, but you know, those sorts of things. So you can see which values to tweak and which values to change, and I even put in some like example pixels here that are just commented out that you could just turn on again so that you can see that you could have more pixels turned on in the first row and stuff like that. And then at the beginning row is the binary code for the number, so 0 to 255 of which rule. And then I describe all of those things, and so it's there, play with it, have something fun. I'm a bit of a perfectionist, so I didn't take an image and then slice something out of it that looked nice. I wanted something that looked good in a knittable scarf width, but that's just me. You could also like generate something much wider and take an interesting slice out of it and then knit that. I like the black edges and showing that those are actually, you know, turned off pixels, and that's the way it works, but that's just my mathematical perfectionism. That has nothing to do with things that look good for other people. So, a PDF copy of it. It's called The Algorithmic Beauty of Seashells, and it is amazing. It's this guy that became obsessed with modeling the patterns that are on seashells mathematically. And he wrote in, I think, Fortran originally, and then in BASIC he wrote, so I have the software running. He wrote in Fortran originally and then rewrote it in BASIC, and I think his son rewrote it in C, and then the software shells and the computer outputs and everything, and it's, I mean, it goes through step by step from the most uncomplicated to the most complicated modeling of the seashell, which they go into 3D worlds and 3D forms of how it, not just the pattern that's on the shell, but how the shell is created and how you would model that if you were going to create a virtual reality with seashells. Go ahead and rewrite it, because once I took a look at it, it's insane. It's this most spaghetti code you've ever seen. And the interface looks like this. So we're talking, you know, not very pretty. And here's all of the, yeah. Here are all of the seashells that you could possibly model. And then there's some notes in there. So if you like scroll through there, he could be like, you change this value to this if you want to change it in this way. And there's like all these little notes in there, but it's completely insane. But if you want to, for example, run the one I used, which is Symbiol Vespertil, I wrote down all these codes today so I didn't have to read through them. Is this one, except with a more pixely view. So basically reducing it to a more pixely view. So that's, if you can look at my IU, which is this part here, and this part you can actually redefine in the program. But if I restart it again, it's slightly different each time. So even with the same row, you're gonna have provably unique shawls or patterns or fabric of whatever you generate, and then you can keep going. So this is the beginning, right? So here's a new beginning, and then you hit next is what comes next, and you can just keep going and going and going and going. And you could knit really long, non-repeating fabrics.
So it's not deterministic, there is some randomness?
Yeah, so the way all of it works is in the book, and it's written out, like you have all the math, all of the theory on how all this like enzymes work, and you know, physically in nature how they work, and how all the mathematical formulas work. Really beautiful read. I really recommend getting the book. There's a sister book called The Algorithmic Beauty of As Good. I recommend this one a lot better. There are two different authors.
Well, I think there's even a third one about sponges.
Yeah, I haven't read that one yet. All this stuff, and then if you hit enter again, it tells you what all of the values, like the key values are, like the starting values, and he goes into all of the, like, what all of these mean mathematically in the book. And he gives you the written out formula. So if you wanted to calculate it by hand, you could. I don't know why, but you could do that. And then, which is, that's Conus textile,
Nice.
or the textile cone shell, which I thought would be really nice to make into a textile. But then again, you can also pixelize it into two colors. And yeah, it's really, really cool. Like, it's very subtle the way it changes with the same initial conditions, but you can see that it's slightly different. And then you can continue if you wanted to knit a really long piece. There's also a way in the program to extend this like starting row to be longer. But I would, before you really delve deep into it, I would more likely recommend that you rewrite it. I started learning Clojure this year to try to write more elegant mathematical algorithms, because it's a Lisp-based language, which is much friendlier if you're starting with a mathematical formula. But you could, I think you could write it in Erlang or Go would be also doable if you could like rewrite some of the software from the book. But it's not just a different color, it's also a different, so it's with the same generative row, but it's provably unique from the first one. So it's, you can see them side by side, but this one has like this big pattern here that doesn't have there. Yeah. So, yeah, this is also doesn't really output like an image file that you could use. So what I did is I went ahead and did screenshots, and then I wrote a little bit of code to repixelize, so because this is actually too high a resolution for my knitting machine.
I like you to show me that, because that's always my trouble. And I was like thinking of ways
I did a lot of it by hand. It's not very pretty. So
yeah, that's always a problem knitting. So.
Yeah, so that's why I think if you rewrote this, or if you rewrote something that was similar to it, even in processing, then you would have something that is directly in the right width for the machine, and then also the right image format. So Yeah, seashells. And the last thing I have to show, which I think everybody knows is Game of Life, is finding something in still in Game of Life that looks pretty to knit. Because here, I'll show you here. So Game of Life is actually a moving thing. So here it is step by step. This is a nice puffer, which I just knit onto our ETIB banner. But it's not really a static thing, and I don't know if any of you know the software. It's open source called Golly.
Yeah, it's really good.
And Golly doesn't just do Game of Life, it does all kinds of cellular automata. It's open source. The only problem is they don't really do export to image.
No, yeah.
There's a plugin for it. There's a plugin for it. But you have to compile it with the right Python libraries for your machine, and this machine I didn't want to reinstall it, so I didn't get those. But there's an extra Python plugin that someone wrote to export it to an image with the pixels without any graph, because you can see there's like little graph bars between the pixels here. So, or use a processing example of Game of Life, and then I don't know how you're going to input your starting values, because that's kind of a pain. Because if it's like a complicated image like this puffer, but I don't know. I haven't really played with Game of Life and processing.
Does this thing have a special format for like the initial configurations, or does it just read images?
I think it has a special format, and you can save them in that format and share them among people.
Okay.
Or you can, and it has all these cut and paste functions. Mm-hmm. So it's like a graphics program, pixely graphics program for cellular automata. But you can also just hit. Anyway, this is really fun, but it would be more fun if it were moving, and knitting is, unless you're Sam Meach.
Yeah, we have to ask.
Not moving, so maybe Sam Meach will knit like, the first 255 iterations of this puffer, and then make an animation out of it, and we will all be like happy campers. I think we will have like satisfied that bug. I have an example of this knit out. Really happy because it has the hacker symbol glider as this still in it. So I was like, well, this is really important. I know it doesn't look important, but it's very important. So I was really happy that it was in there, because then maybe somebody walking by will be like, that's the symbol for hacker. I'm going in that space. This is our idea. We wanted to make a banner for outside. Well, Victoria made a bunch of lovely banners, but the idea was to make another one where you could tell what we do from the outside. I couldn't get it to reconcile either, so this is their reconcile basis, because they have it in a weird, it's like a weird kind of one-off basis.
Eingelegt.
And it's a whole project,
hours, and then they have another training event.
Yeah. And a whole traveling